In this video, I'm going to explain to you how to calculate the pH of salts. There are a couple things you want to determine to successfully calculate the pH of a salt, so we'll go in order. The first thing you want to determine is if there are any spectator ions in your reaction, and I'll speak more about spectator ions as we go into the practice. The second thing is the type of salt you're dealing with. In the previous video, I actually explained how to determine if a salt is acidic, basic, or neutral. So if you have any questions about that, I would recommend watching that video or leaving a comment so that I can reply to you. But depending on the type of salt you have, you want to determine if you have the correct data or information to actually solve the problem. So if you have an acidic salt and they give you the Kb, you want to make sure that you actually get the Ka, and that's the point of this formula right here. So just as a quick reminder, the Kw is equal to the Ka times the Kb. And the Kw has a value of 1 times 10 to the negative 14. So that is one of the most crucial steps to make sure that all of your work is actually going to give you the correct result. After you figure that out, you write the equation and you want to use an ice table to determine the concentration and from that determine the pH or the pOH. So just like the type of salt, depending on if you have the Kb or the Ka, you're going to get the concentration of the hydrogen ion or hydroxide ion. So you want to make sure you're actually calculating the right thing to obtain the pH or the pOH. And if you obtain either of them and you're looking for the other one, remember that you can use this formula right here. So the pH plus the pOH is equal to 14. So now let's put all of this into practice. In this problem, we want to determine the pH of 0.1 molar of sodium acetate. So sodium acetate is a salt, as you can see right here. It's been formed from reacting an acid with a base. And we know that the Ka of acetic acid is 1.75 times 10 to the negative 5. So following the steps I gave you before, we want to start by figuring out if we have any spectator ions. So the way we do that is we'll write the formula of the ionization of the salt in water. So starting with sodium acetate, we'll split up the ions. So we'll have Na plus the acetate, CH3COO minus, and water. And then we have equilibrium errors, and I'll continue the equation below it. So the water right here is going to give a hydrogen to the acetate, and we'll end up with Na plus CH3COOH and the hydroxide ion. So from this we can determine which of these is our spectator ion, and as a definition, spectator ion is one that will show up in the reactants and the products side of the equation. So the one in this case would be the sodium, and we'll just eliminate it because it serves no purpose for this problem. So now that we got that out of the way, we can use this to set up ice, the ice table. But before that, remember the step that came before, and that will be determining if we have an acidic or a basic salt. So just quickly, we'll look at our salt, and we have to determine what the reactants that form that salt were. So because we have the sodium and the acetate, and the salt comes from reacting an acid with a base, we can figure out that the sodium could come from sodium hydroxide, which is a strong base, and the acetate is actually not part of any of the strong acids. So combining or reacting a strong base with a weak acid will tell you that the salt is actually basic. So we have a problem here because we have a Ka and we have a basic salt. So just using the formula I provided before, Kw is Ka times Kb, determine the Kb for the solution. So we know that the Kw is the Ka times the Kb, So from that we can determine that the Kb is actually equal to the Kw over the Ka. So just to save some space, I'll write it as 1 times 10 to the negative 14 because that's the value of the Kw, and we have for the Ka 1.75 times 10 to the negative 5. So that would be equal to 5.71 times 10 to the negative 10. So just to sum it up, we now have the Kb for this basic salt, and we'll move on. I will set up this equation right here without the sodiums in the ice table, and we can continue solving this problem. So here's our ice table. I took off the sodiums because they're spectator ions, and we can also cancel the water because it doesn't play any role here. Let's start with the I, which stands for the initial concentration, and we know that we started with 0.1 molar of sodium acetate, and that's what we had here, and we can just write it as 0.1. We didn't have any of the products, so they're 0, and what is going to change is that we're going to call this plus x because we will be forming product, and we will be losing that same amount of reactant. So in this case it will be minus x here, and that C would stand for change, and that's what just happened. And when we add the initial and the change, we'll get the concentration at equilibrium, which is the E, and that ends up being 0.1 minus x, and x. So now that we know the concentrations of everything at equilibrium, we can now set up the equation for Kb, which is products over reactants, and that will be the concentration of this times the concentration of this over the concentration of this. So in the next page, I'll write it as x squared because it will be this times this over 0.1 minus x. So let's do that right now. The Kb is equal to products over reactants. We know that our products are x squared, and our reactant is 0.1 minus x. As always, we can cancel this x right here, making this problem a lot easier to solve. Now our value for Kb, which we determined before we started the ice table, was 5.71 times 10 to the negative 10. So this would end up being x squared is equal to 0.1 times 5.71 times 10 to the negative 10, and that is equal to 5.71 times 10 to the negative 11. And when we get the square root of that, we'll get that x is equal to 7.56 times 10 to the negative 6. And we also know from our ice table, if you remember, that x was actually the concentration of our products, of one of our products, and in this case we can say that this is actually equal to the concentration of OH minus. And when we have the concentration of OH minus, that means that we can get the POH, not the pH of this reaction. So take that into consideration. The POH is equal to the negative log of the concentration of hydroxide, which we just determined. So the negative log of 7.56 times 10 to the negative 6 would be equal to 5.12. And we wanted to get the pH of the salt, not the POH. So we just need to do one more final step, and that is that the pH is equal to 14 minus the POH, and that is equal to 8.88. About. This is remember that this is somewhat rounded, so it can actually vary a little bit. And that pretty much sums it up for this video. My biggest tip about calculating the pH of salts is to always take into consideration if you're dealing with an acidic or a basic salt, because you can get things like we just saw, in which you have the Ka for a basic salt, and that will end up giving you the incorrect result. And also pay attention to if you want the pH or the pOH, and what you will be getting, as just in this scenario in which we had the Kb and we obtained the pOH, but we wanted the pH. So that could be an extra step to have. So thank you for watching this video. I hope you liked it and found it useful. If you have any comments or questions, don't hesitate asking us. And if you enjoyed the video, please be sure to give a like and subscribe if you want to see more videos like this one.